Hello everyone and welcome back. In this part of the tutorial, we will be working on the client service that our Unreal Engine game client will use to communicate with the Amazon GameLift and DynamoDB services. These components of the client service will be used primarily for matchmaking purposes. Like in past parts of the tutorial, we will be writing AWS Lambda functions, one for making a matchmaking request, one for canceling a matchmaking request, one for reading the matchmaking tickets table, and one for retrieving player data. Each of these Lambda functions will be accessible from an Amazon API Gateway REST API that is Cognito authorized. Therefore, only authenticated clients will be able to call these API methods using a valid access token. And one more thing before we begin, if you have made it this far in the tutorial series and want to help support the channel, then please consider supporting us on Patreon. We appreciate every single donation, no matter what amount, because it helps us create more content. But now let's get back to the video. To start, go to the AWS Lambda console and create a new function. The first function that we're going to write is for retrieving player data. This Lambda function will be used to display a player's wins and losses on the client front end and to calculate the player's skill attribute for a matchmaking request. So let's name this function getPlayerData and then click on create function. And since this function will be using the AWS SDK, we will need to add a Lambda layer the same way that we have been doing throughout this tutorial series. So click on where it says layers underneath the function name here, and then click on add a layer. And then for the name, click on this drop down menu and select the layer that we've always been using, so GameLift tutorial layer. As for the version, select 1 just like we've always been doing and click on add. Okay, now let's scroll down to the inline code editor, and inside here, let's zoom in by pressing Ctrl+ a few times. And the first thing we're going to do is import some node modules outside the handler function. So up here, type out const AWS equal require, and in parentheses and in quotes, AWS-SDK. Then on the next line, type out const cognito equal new AWS.cognito identity service provider, and then in parentheses and in squiggly brackets type out region, colon, and then in quotes the code of the region that you're operating in. So for me it's going to be US-East-1. And then on the next line type out const DynamoDB and set that equal to new AWS.DynamoDB, and then in parentheses and in squiggly brackets, same thing as the last line we just typed above, region, colon, and then in quotes the code of the region that you're operating in. Again, for me it's in US-East-1. Now let's go back to the handler function, and to start let's get rid of everything already inside of here and define some local variables. So first one's going to be called response, the next one's going to be called raised error, and the last one will be called access token. Next, we are going to grab the access token from the request header. So to do that, let's first check if the event object passed into this function has a property called headers by typing out if in parentheses event.headers and then squiggly brackets. And if it does, then let's check if the headers contain a field called authorization by writing if in parentheses event.headers and in square brackets and in quotes authorization squiggly bracket. And if it does, then let's set our local access token variable to this authorization header value by typing access token equal event.headers and then in square brackets and in quotes authorization. And even though we covered this in the last part of the tutorial, I just want to remind you guys again that the API endpoint that will route to this Lambda function will be Cognito authorized. So for a client request to even reach this function, that request has to contain an access token via the authorization header. Back to the function. After getting the access token, let's make a variable for the request parameters that we're going to pass to a call to the Cognito getUser function. So type out const cognito request params and set that equal to an object, and this object will have one property called access token, and the value for that property will be the access token variable, and then add a semicolon here. Then let's make another variable called sub, And the reason we are making a variable called sub is that previously in the last part of the tutorial, when we made the players table, we decided that the primary key of each item in that table would be the cognito subclaim of the user that the item referred to. The access token can be used to call the cognitoGetUser function, which will get us all the cognito user pool attributes of the user associated with that access token, including the cognito sub ID. So let's call the getUser function by writing await cognito.getUser and then in parentheses pass in the cognito request params, and then .promise parentheses .then and then in parentheses data arrow squiggly brackets, and then underneath that .catch and then in parentheses arrow squiggly brackets again, and then add a semicolon. And once again, the await, promise, then, and catch keywords are because we are trying to make a asynchronous function synchronous. And if the call to get user was successful, then this then function will get called. And in here, we have to get the cognito sub value. So to do that, let's check if the data object returned from get user contains a property called user attributes by typing out if in parentheses data $data.user attributes and then squiggly brackets. And if the user attributes do exist, let's iterate through them by writing for in parentheses const attribute of data.user attributes squiggly brackets, and let's check if the attribute that we are iterating on is the sub ID by typing out if in parentheses attribute dot name double equal in quotes sub squiggly bracket. And if it is, let's set our local sub variable equal to the value of this sub attribute, which in this case will be attribute.value, and then we will break out of this loop. And if an error occurs while calling the getUser function, then the catch function will be called. So in here, let's set our local raised error variable equal to error. And if an error did occur while calling getUser, then let's return a negative response from this lambda function by checking if the raised error variable was ever set by typing out if in parentheses raised error squiggly bracket. Because the only way that this raised error variable could be populated is if the catch function was invoked. So in here, let's set the response to something negative by typing out response equal squiggly brackets status code :400 comma body :JSON.stringify and in parentheses and in squiggly brackets error :raised error. And then let's add a semicolon here and return the response. So assuming the call to get user went fine, we should have the cognito sub ID associated with the access token inside the event object passed into this function. Let's use that sub ID to construct request parameters for the DynamoDB get item function by typing out const DynamoDB request params, and we're going to set that equal to an object containing a couple properties. The first one will be called table name, and we're going to set that to in quotes players because the table that we will be looking for an item in is called players in this case. And then the second property will be called key, and this key property will be an object with a property called ID because in the players table specifically we set the primary key to be called ID, and this ID property will also be an object containing a property called S because the ID partition / primary key inside this players table is of type string, so S is short for string. So after this colon, we're gonna type out sub because we want to query this players table inside DynamoDB for a specific item by a specific sub ID value. And then don't forget to add a semicolon here at the end. And then let's make a local variable called player data, which we will later use in the response return from this lambda function, assuming the call to the DynamoDB get item function is successful. So let's actually call get item by typing out await DynamoDB.getItem, and then in parentheses we'll pass in the db request params, and then dot promise dot then, and in parentheses data arrow squiggly brackets, and then underneath that dot catch, and in parentheses error arrow squiggly brackets, and then a semicolon at the end. And if the call to get item was successful, then the then function should be invoked. And in here we should check if the data object returned from get item contains a property called item by writing if in parentheses data double ampersand data.item, and then squiggly brackets. If so, then this item object should be the item inside the players table with the same sub-ID as the one belonging to the user linked to the passed-in access token, and subsequently, this item object will also contain the other DynamoDB attributes such as wins and losses. So let's set that local player data object equal to data.item. And then let's make the response to return from this lambda function positive, as well as containing the item from the players table by typing out response equal in squiggly brackets status code colon 200 comma body colon json dot stringify, and then in parentheses and in squiggly brackets player data in quotes, and then colon player data. The reason why we need to set the name of the property in quotes is because in this case the name of the property matches the name of the variable that we are using for the value of the property. So then end this off with a semicolon. And if the request to DynamoDB get item fails, then the catch function will be invoked. So in here, let's make the response to return negative by typing out response equal in squiggly brackets status code colon 400 comma body colon json dot stringify, and then in parentheses and in squiggly brackets error colon error. And then let's add a semicolon here, and finally let's end the function off by typing out return response, and click the save button to save your changes. Now before we test this function, we actually have to modify the permissions of the access policy attached to this function in order to call get item on the players table. So let's scroll up, go to where it says permissions, and then under where it says execution role and role name, click on this hyperlink here, and that should take you to this IAM page, and under where it says permission policies and policy name, just click on your lambda functions policy, and then once this loads up, click on the edit policy button, and then go to the JSON tab. And inside this JSON text editor, let's add another object to the statement array. So after this last closing bracket before this closing square bracket, type out a comma and then squiggly brackets, and then in quotes effect colon in quotes again allow comma in quotes action, and then colon in quotes dynamo db colon get item, and then comma in quotes resource, and then colon in quotes. This will be the resource ARN value of your players table in DynamoDB. So go to the AWS DynamoDB dashboard, then go to the tables tab, and then click on the name of the players table, and then scroll down, and underneath where it says table details at the very bottom to the right of where it says Amazon resource name, just copy this value and then go back to the IAM page where you were editing the policy attached to your lambda function, and paste that ARN value inside the quotes by where it says resource, and then click on review policy, and then click on save changes. Now your lambda function should have permission to call get item on the players table. So now let's go back to the lambda function so that we can test it. And remember that the code for this lambda function will be contained in a GitHub repository that will contain all the lambda code written throughout this tutorial series. And for this function, we also have a folder called test events, just like we do for every lambda function. And let's start with the invalid access token event.txt file. So just copy what's inside here, then go back to Lambda, and let's configure a new test event by clicking on this drop down that says select the test event, then click on configure test events and make sure create new test event is selected, and it should be by default when you're creating your first test event for a function. And we'll name this event invalid access token event, and then inside this text editor window just paste the text from that text file from that GitHub repo inside, and then click on create, and then click on the test button to test your Lambda function with that event. And under where it says execution results succeeded, if you expand the details button, you should see a response saying error message invalid access token, because as you guys saw in that test event, the access token value that we passed in was dummy, so that's obviously not valid. Now let's actually test this function with a valid access token by going to the Cognito dashboard, then go to manage user pools, select your user pool, and then on the left side go to the app client settings, and let's launch our hosted UI, because we're going to use the hosted UI to get a code that we can then exchange for tokens using the Lambda function that we made in the last part of the tutorial. So let's just log in by typing in a username and password, click the sign in button, and then in the URL here, copy the code, and then go back to Lambda, and then go to functions, and let's go to that exchange code for tokens function that we made again before, and then click on this drop down menu, click on configure test events, and if you were following when we were testing in the last video, you should have an event called tokens generated event. So make sure edit save test events is selected, as well as the tokens generated event under where it says save test events, and inside the JSON formatted text for this event where it says code to the right of it, let's replace the value for the code with the new code that we just made. Click on save, and then click on test, and then under where it says execution result succeeded, let's expand the details and find the access token. So for me it's right here, and then just copy the value because we're going to need it for our get player data function. So now go back to the get player data lambda function and click on the drop down menu here and select configure test events, because now we're going to make a new test event. So make sure create new test event is selected instead of edit save test events, and for the event name this time we're going to be calling this valid access token event, because now we're going to be using a valid access token. So where it says dummy here inside this JSON formatted text, replace that with the access token that you copied from the exchange code for tokens function, and then click on create and click on test. And this time under where it says execution results succeeded, if you click on details, you should see a response with status code 200 this time instead of 400 like we saw earlier. And inside the body of this response, you should see a player data object with not only the sub ID value but also the losses and wins associated with that player item inside the table. And if that went as expected, then let's move on to the next lambda function we have to write by going back to functions and then click on create function. And this function will be responsible for making a matchmaking request, and it relies heavily on the GameLift start matchmaking function. So we're going to call this function start matchmaking, and then go ahead and click on create function. And as I just mentioned, we will be using the GameLift AWS SDK library, so we need a lambda layer. Just like last time, click on layers and then click on add a layer, and then for the name, select the layer that you've always been using, and then for the version, for me it's going to be version 1, and then click on add. And then we can start coding, so scroll down to the inline code editor, and inside here let's zoom in by pressing Ctrl+ a few times. And the first thing we are going to do, outside of the handler function, let's import some node modules. So type out const AWS equal require in parentheses and in quotes AWS SDK, and then const lambda equal new AWS dot lambda in parentheses and in squiggly brackets region colon and in quotes the code of the region that you're operating in. For me, it's going to be US-East-1. And then const GameLift equal new AWS.GameLift, and then in parentheses and in squiggly brackets, again, region colon in quotes the code of the region you're operating in. Now back to the handler function, let's get rid of everything that's already in here. And let's replace that with some local variables. So the first one will be called response. The next one will be called raised error. And then the last one will be called latency map. And you may be wondering, what is this latency map variable going to be used for? So GameLift has a feature called FleetIQ. And essentially GameLift FleetIQ is an extra layer of logic on top of Amazon EC2 and auto-scaling, whose primary goal is to locate the best possible game server to host a game session and give players an optimal gameplay experience. So what does that mean? When a potential match is created, FleetIQ will rank the fleet destinations in a queue by several factors. Those factors include player latency data, spot interruption rates, EC2 pricing, whether or not a fleet has an available server process for hosting a new game session, and the queue's default list order. And based off that ranking, the top fleet will be chosen to host a game session for that match, if possible. Then hopefully a game server process on an instance, usually one that is already hosting other game sessions, in that fleet will be claimed for a new game session for that potential match. And all the players in that match will get an update through their matchmaking tickets with connection details for joining the game server. One of the factors mentioned was player latency data. By the way, forgot to mention, latency is another word for network lag, which means how long on average it takes for data to travel between the client and the server. Now, where does this player latency data come from? That's where this latency map variable comes in. Each player in their matchmaking request will specify a latency map object that will contain their latency for different regions. Later in this tutorial series, I will show you guys how to calculate a client's latency with respect to the Amazon GameLift servers in one region. So technically, we won't be testing the actual player latency optimization capabilities of FleetIQ in this tutorial. But once I show you guys how to get the latency in one region, you can then apply the same logic to multiple regions on your own. Also, if you truly want to experiment with FleetIQ and player latency optimization, then you will also need fleets in different regions, and those fleets will have to be added to your queue. Just to repeat, to keep this series short, we will not be covering that directly, so if you want, you can try all of that in your free time. FleetIQ is actually really interesting, and although we won't be going over FleetIQ in detail in this video, I highly encourage you guys to check out the description below for links to articles that do go over FleetIQ in detail. With that all said, we are going to assume that the latency map containing all the various latencies for different regions will be passed in through the request body. So let's check if there's a body object in the event object passed into this function by typing out if in parentheses event.body squiggly brackets, and if there is, let's parse the event body because it will be in the form of a JSON string by typing out const body equal JSON.parse in parentheses event.body. And then let's check inside this body object if there is a latency map property by typing out if in parentheses body.latency map squiggly bracket, and if there is, let's set our latency map local variable equal to body.latency map. And if the request body doesn't contain a latency map property, then let's make the response to return from this lambda function negative by first checking if there was no latency map by typing out if in parentheses not latency map, then squiggly brackets, and we'll set response equal to squiggly bracket status code colon 400 comma body colon JSON dot stringify in parentheses and in squiggly brackets error colon and then in quotes incoming request did not have a latency map. and then let's add a semicolon here and return the response. Now, each matchmaking request to our matchmaker should specify a player skill attribute because we define one in the matchmaking rule set for that matchmaker. And I mentioned earlier that we will be using player wins and losses to calculate the value for the skill attribute, and conveniently we just wrote a function that will get us that information. So let's make the request object for the call to the lambda invoke function. So type out const lambda request params, set that equal to an object, and this object will contain two properties. The first one will be called function name, and the value for that will be, in quotes, the name of the lambda function that we plan to invoke, and we just wrote it, so it's going to be called getPlayerData. The second property will be called payload, and the value for this will be in the form of a binary string, in our case specifically a JSON formatted string, basically the event object that gets passed to the function that you plan to invoke. So in this case, we're going to take the event object that this function received and just pass that along to the getPlayerData function by typing out JSON.stringify in parentheses event, and then add a semicolon here. Keep in mind here that the API endpoint that routes to this function will be cognito authorized. So incoming event objects to this lambda function, to this start matchmaking lambda function, should contain an authorization header with an access token. Otherwise, if we pass in the event object that this function gets to getPlayerData, it won't work because, like we just saw earlier, the getPlayerData function requires an access token passing through the authorization header in the event object, because we use that access token to get a cognito sub ID that we use to query the DynamoDB players table. And then next we're going to make a local variable called playerData to store the player data that we receive from this getPlayerData lambda function. Now let's actually invoke the getPlayerData function by typing out await lambda.invoke. In parentheses we'll pass in the lambda request params, and then .promise .then in parentheses data arrow squiggly brackets, and then underneath that we'll have a .catch in parentheses error arrow squiggly brackets. And I made a typo, I misspelled catch, and don't forget to add a semicolon at the end here. And if the function was successfully called, then the then function will be invoked, and in here let's check if the data object return contains a payload property by typing out if in parentheses data double ampersand data.payload, and then in squiggly brackets, if it does, this payload property will be in the form of a JSON formatted string. So let's convert this to a JSON object by typing out const payload equal json.parse in parentheses data.payload. And this payload object should have a body property because the response returned from the getPlayerData lambda function has a body property. So let's check if in parentheses payload dot body and then squiggly brackets. If there is a body in this response payload object, then let's convert that to a JSON object since the body is generally of type JSON formatted string. So type out const payload body equal json.parse in parentheses payload dot body. And let's set our local player data object variable equal to payload body.player data. Also, if something went wrong while calling the getPlayerData function, then this catch function will be invoked. So in here, let's set our local raised error variable equal to error so that we can check it after this lambda invoke function is finished executing. And now we have to check for two things. One, if the raised error variable was ever set, because the only way it can equal a non-undefined equivalent value is if the catch function was invoked. And if that is the case, then for whatever reason there was an error while invoking the getPlayerData lambda function. And we have to make the response to return from this lambda function negative. So type out if in parentheses raised error squiggly brackets response equal in squiggly brackets status code colon 400 comma body colon JSON dot stringify in parentheses and in squiggly brackets error colon raised error. Let's add a semicolon and return response. The other case in which we should also return a negative response is when the getPlayerData function did return a response, but that response did not contain any player data. So to do that, type out else if in parentheses not player data, and then in squiggly brackets response equal in squiggly brackets status code colon 400 comma body colon JSON dot stringify in parentheses and in squiggly brackets error colon in quotes unable to retrieve player data. And let's add a semicolon here and once again return response. And if neither of those cases are true, then the player data variable should be equal to the player item object associated with the client making a request to this lambda function. So let's extract the different properties of this player item by typing out const player ID equal player data dot ID dot s. And this is the partition key of the players table, which is also the cognito sub ID. Next up we have const player wins, and we'll set that equal to parse int. In parentheses, this function will take in two parameters. The first one will be player data dot wins dot n, and then the second parameter will be 10. And the reason why we're using the parse int function is because player data dot wins dot n as well as player data dot losses dot n, even though they are technically number attributes, they will come in as strings. So we have to convert the string to a number. So we use the parse int function, and we pass in the number 10 as the second parameter to note that we want to convert the first parameter to an integer of type decimal rather than hexadecimal or binary, for example. Let's do the exact same thing for player losses. So we'll set that equal to parse int in parentheses player data dot losses dot n comma 10, and then lastly we'll just make a variable called total games played, which will equal the sum of player wins and player losses. So like I mentioned earlier, I want to use the wins and losses to calculate the player skill attribute for a matchmaking request. So let's make a local variable called player skill. And first, if this is the player's very first game played, I'm just going to set the player skill to a hard-coded number. So let's check if the number of games played by this player is less than 1 by typing out if in parentheses total games played less than 1 and then squiggly brackets, and if it is, let's just set player skill equal to 50. Otherwise, if this player has played at least one game, then let's set the player skill to be the win percentage of this player. So type out else, squiggly bracket, and then inside here, player skill equal in parentheses player wins divided by total games played, and then outside the parentheses times 100. Now remember, you can do anything you want for this player skill attribute. In fact, for any attribute you define in your rule set. I'm just using a very simple formula for this tutorial. For an actual game, I would probably recommend something more complex. Now we should have everything we need for a matchmaking request. So let's construct the request parameters for a call to the GameLift start matchmaking function by typing out const GameLift request params, and we'll set this equal to an object, and this object will contain a couple properties here. The first one will be configuration name, and the value for the configuration name will be in quotes the name of our matchmaker. So in our case it will be GameLift tutorial matchmaker, or whatever you named your matchmaking configuration. The next property will be called players, and this property is actually going to be an array of objects. Now for this tutorial we are not going to be going in depth into matchmaking requests containing multiple players. So in this tutorial we are assuming that each matchmaking request will have at most one player in it. So inside these square brackets, let's type out some squiggly brackets, And let me just fix this formatting here. And inside these squiggly brackets in this one player object in this player's array, we will have a few properties. The first one will be called latency in ms. The ms stands for milliseconds, and this will be equal to the latency map passed in through the request event object. The second property will be the player ID. For this, we are going to be using the Cognito sub ID, aka the partition key of the player item that we retrieved from the player's DynamoDB table. So we store that in the player ID local variable, and then the last property will be called player attributes, and this will be an array. Or sorry, this won't be an array, this will be an object. And in our case, in our rule set, we really only have one player attribute, and that was called skill. And this skill attribute will be an object containing one property called n, because we made the skill attribute a number technically. And we are going to pass in for n of skill of player attributes the player skill local variable. And let's add a semicolon here at the end. And for debugging purposes, this is just something I like to do, so you don't have to do this, but I prefer to log these GameLift request parameters to make sure that everything in the request is being populated as it should be. So let's type out console.log in parentheses and in quotes matchmaking request colon and then plus json.stringify in parentheses GameLift request params. And let's also make a local variable for the ticket ID that we will be returning from this lambda function upon a successful response from start matchmaking. So type out let ticket ID. Now let's actually call GameLift start matchmaking by writing await GameLift.start matchmaking, and then in parentheses we'll pass in GameLift request params, and then we'll have dot promise parentheses dot then in parentheses data arrow squiggly brackets, and then underneath that we'll have dot catch in parentheses arrow squiggly brackets and a semicolon. And remember, once again, the keywords await, promise, then, and catch are so that we can call an asynchronous function synchronously. And if the call to start matchmaking was successful, then the then function should be invoked, and we should check if the data object returned has a matchmaking ticket object property. So type out if in parentheses data double ampersand data dot matchmaking ticket and then squiggly brackets. If it does, let's set our local ticket ID variable equal to data dot matchmaking ticket dot ticket ID. And let's also make the response to return from this lambda function positive by typing out response equal in squiggly brackets status code colon 200 comma body colon json.stringify in parentheses and in squiggly brackets in quotes ticket ID and then colon ticket ID. Again, the reason why the property name in this case is in quotes is because the value that we are using for this property is a variable with the same name as the property name. And then let's add a semicolon here. I just want to point out the reason we are only sending back the ticket ID is that the matchmaking ticket object at this point, right after we made a matchmaking request, won't contain that much useful information in my opinion. The information from FlexMatch event notifications that is being sent to the SNS topic and had stored in the matchmaking tickets DynamoDB table is what I believe is actually useful, and the items in that table are keyed by ticket ID. And if something went wrong while calling GameLift start matchmaking, then the catch function will be invoked. And we should make the response here to return negative in that case by writing response equal squiggly brackets status code colon 400 comma body colon json.stringify in parentheses and in squiggly brackets error colon error. And then let's add a semicolon here, and finally we can end this function by returning the response. And don't forget to click save up here to save your changes. So now we have to modify the access permissions of this lambda function similar to how we did it for the get player data function. So scroll up, click on where it says permissions, and then under where it says execution role and role name, just click on the start matchmaking role. And then that should take you to this IM management console page. And then under where it says permissions, policies, and policy name, just click on the policy attached to your lambda function. And then from here, click on edit policy, and then click on this JSON tab here. And then here we're going to be adding two objects to this statement array. The first one will be for allowing this lambda function to invoke the get player data lambda function, and the second one will be for allowing this lambda function to call GameLift start matchmaking. So right before this last closing square bracket, after this closing squiggly bracket, type a comma and then type some squiggly brackets and in quotes effect, colon in quotes allow, comma in quotes action, and then colon, oh, I misspelled action, and then colon in quotes lambda colon invoke function, comma in quotes resource, and then colon in quotes go to the get player data lambda function, and at the top right corner you should see in bold the letters ARN. Click on this copy clipboard button to the right of this ARN value, and then go back to the IM page and then paste in that value for the resource here. And then let's add another object. So comma, squiggly brackets again, and then in quotes effect, colon in quotes allow, and then comma in quotes action, colon in quotes GameLift, colon start matchmaking, and then comma, and then in quotes resource, and then colon in quotes star. Click on review policy now, and then click on save changes. Now go back to the lambda function and keep in mind that the code for this function, along with all the other lambda code, will be in a GitHub repository linked in the description below. There will also be test cases for each function, so specifically for the start matchmaking function, let's open up the text file called invalidaccesstokenEvent.txt, copy the text inside, then go back to the start matchmaking lambda function, and let's make a new test event. So click on this drop down menu, click on configure test events. So I've actually already made this test event, but normally if you haven't made the test event, just like we've been doing before, make sure create new test event is selected, and then inside this text box just paste the text that you just copied inside here, and of course name the event anything you want to. But again, I've already made this event. I named it invalid access token event, so for you guys, you can name it anything you want. So I'm not going to make a new test event, but that's because, again, I've already made it. And one thing I want you guys to note here is that the latency map that's going to be passing through the body property of this event object, it will depend on the region that you're operating in. So that's why I have in here insert region code here, because I know for you guys it might be different. You guys might not be operating in the US East 1 region. For me, I am operating in US East 1, so I'm going to write US East 1 for this value here. Now, you should use the code associated with the region that you're operating in. Once you've done that, click on save, or if you're making this event for the same time, for this first time, it should say create. Just click on whatever one, and then click on test. And once the function is finished executing, you should see execution results exceeded, and then click on details to expand. And this response makes sense. It has an error message saying unable to retrieve player data. And the reason that makes sense is that we pass in a invalid access token. So because we pass in an invalid access token, there's no sub ID associated with that access token, so there's nothing to get from the player's DynamoDB table. Now let's test this function with a valid access token. So we know how to get one. We just did it for the get player data function. If you still have one from when we tested get player data and it's not expired, then feel free to use that one. But mine is definitely expired, so I'm going to make a new one by going to the Amazon Cognito user pool settings, specifically the app client settings. And from here, I will launch the hosted UI and I will log in with a username and password. Then I will sign in. And using the code, the authorization code from this URL, I'm going to copy it, go back to the exchange code for tokens lambda function, select the drop-down menu, select configure test events, make sure I'm on edit save test events, and make sure I have the tokens generated event selected, and I'm going to replace this code value here inside the body with that code that I just got from the hosted UI. Then I'm going to click save, and then I'm going to click test. And from here, I'm going to go up, I'm going to go to the execution results succeeded logs. I'm going to click on the details to expand, and I'm going to copy the access token from the response. And I think I might have passed it. Okay. So I'm going to copy this. I'm going to go back to the start matchmaking lambda function. I'm going to go back to this drop-down menu and click on configure test events. This time I'm going to select on create new test event. And inside for the event name, I'm going to call this valid access token event. And for the headers, specifically the authorization header, instead of dummy, I'm going to replace that with the token that I just copied from the exchange code for tokens function and paste it in there. I'm going to click on create, and then I'm going to click on test. Okay, so it seems like everything worked. We got a successful response with a ticket ID, but if we go back to DynamoDB, specifically the matchmaking tickets table, and we go to items, you will see, because it took me too long to actually record, that there is an item in there with that exact same ticket ID. So as you notice, it's the exact same ticket ID. The type is matchmaking ticket, or sorry, the type of this item is matchmaking timed out, because we set the timeout value in our matchmaker to be a pretty low value. We set it to be 60 seconds, which is okay, but in between that 60 seconds, like before the ticket timed out, there was actually no item inside this table. There was no matchmaking timed out item for this ticket ID, because if we go back to start matchmaking and we click test again to generate another matchmaking request ticket for this exact same user. By the way, you have, for now, please do not use an access token from another user. Make sure for these tests you are signing in with the same user. If we go back to DynamoDB and request and refresh this time, you'll notice, because the request didn't time out, that there is no second item was written yet for this new ticket ID. Right, so, but if we wait a little longer, right, if we keep refreshing, we wait the full 60 seconds out, then eventually there will be an item of type matchmaking timed out. Now the question is, how do we know that the matchmaking request was actually made before the request times out? Well, first, if we go to the lambda function, one sign is simple. We had a log statement, right, where we print out the GameLift request parameters, and it seems like the values are populated. We even see the default skill value of 50. We see our latency map passed into the test event. If we go to the AWS Management Console and we go to CloudWatch, so let's look up CloudWatch inside the search bar, select CloudWatch. Remember a while ago in the tutorial, we actually added a console log statement in our track events function. That's the lambda function that's subscribed to the SNS topic that is getting GameLift Flex Match event notifications. So let's go from here to log groups on the left side. And if we click on the track events function, under where it says log groups, and select the newest one, make sure you have the sorted by latest event time. I believe it should be sorted by default. And if we click on this first log stream at the top here, and you're going to see a decent amount of logs from here, but if we look at the very latest log message, so at the very bottom, like before it says end request ID, yada yada yada, we just expand this, you will get, we printed out the full message from from GameLift. So this is the message that FlexMatch sends to our SNS topic. And you'll notice a couple of things, right? So the ticket ID was the same one that was returned from that start matchmaking function. And the reason now it says timed out, if you go down the type, it says matchmaking timed out. So if you go to the log message before that, so don't expand the ones that start with start, report, or end in all caps. So let's go to this next one here. And you'll notice at one point, same ticket ID, right? But now the type is matchmaking searching. So the request did initiate at one point, and then after 60 seconds, because no potential matches were made, because we didn't have another player make a match, or sorry, we didn't have another player make another matchmaking request, so we couldn't make a potential match because in our matchmaker we require at least 2 players in one match. So if we go back to DynamoDB, now if you click refresh, you'll see another item in this table of matchmaking timed out for this ticket ID. Another thing I want to point out first, what is CloudWatch? CloudWatch is an AWS service that collects monitoring and operational data in the form of logs, metrics, and events, and provides that data to you in a nice unified dashboard view. So for example, our lambda functions, they generate logs, and in CloudWatch, a log group will be made for each lambda function. And in each lambda function log group, the log messages will be scattered across different log streams. Now, in this specific scenario, a bunch of log messages were condensed into one log stream. Now, that may not always be the case. Each of these log messages could have been in their own log stream. In that case, you would have to go back to to your functions log group and look at the logs in each stream separately. Also, for testing the start matchmaking lambda function, for the valid access token event, please only use access tokens associated for one user. Because if you start playing around with different test events with access tokens from different users in quick succession, then a match will be made, or a match could be made, and therefore a game session will be made. But right now we did not implement any game session cleanup logic, so if you make a match now, then you will start getting charged for your fleet. And not only that, when we get to later parts in the tutorial, we may not have any available server processes to host a new game session if you made a bunch of new matches, and thereby we won't be able to get into a server process for a match when we need to. In these cases, we have to terminate the fleet, so only test with one user for this function. It will make sense in future parts of the tutorial, trust me. And one last test that I want to perform is I want to make 2 requests with the same access token very quickly. So let's X out of here. Let's click test once, and then once that finishes, we will click test again. And the reason why I did this is because you guys actually may have already noticed this, but if we go back to DynamoDB, the matchmaking tickets table specifically, we click on refresh, you'll see a new item of matchmaking canceled. And if you notice closely, I know it was really quick, but this ticket ID is not the ticket ID of the last test event that we ran. It's actually the ticket ID of the first test event. Well, not the very first, but like the second to last test event that we just ran. It's that the ticket ID returned from that response. And basically, if you make a request with the same player ID as one that is already in an existing and active matchmaking request, and what GameLift does is that it will cancel the old request, which is what you see here in this item in the table, and then it will make a new request for that player ID. This is some very simple logic just to prevent a player from spamming matchmaking requests, so each user can only have one active matchmaking request at a time. And if I click refresh again, maybe, yeah, so as you can see, that ticket just timed out. If we go back to the lambda function, we'll notice that it was indeed that very latest ticket ID that we just got has just timed out. Alright, now let's go back to lambda and make a new function. So let's go back to functions and then click on create function. And this function will be for canceling a matchmaking request manually, not like how FlexMatch will do it automatically for us in some instances, as you just saw earlier. So for the function name, let's call this stop matchmaking, because this lambda function will rely heavily on the GameLift stop matchmaking function. And then click on create function. And like I just mentioned, this lambda function will rely on the AWS SDK. So let's add a lambda layer just like how we have always been doing it. So click on where it says layers under the function name, and then click on add a layer, and then under the name, select the layer that you've been using throughout this tutorial series. And then for the version, let's select 1, and then click on add. Alright, now we can start coding, so go down and inside this inline code editor, let's press Ctrl+ a few times to zoom in, and let's import some node modules outside of this handler function by typing const aws equal require in parentheses and in quotes aws-sdk. And then on the next line, const GameLift equal new aws.GameLift, and then in parentheses and in squiggly brackets, region colon in quotes the code of the region that you're operating in. So for me, it'll be US-East-1. And inside the handler function, let's get rid of everything that's already inside here by default and define some local variables, one called response and the other called ticket ID. Request to this lambda function should specify the ID of the matchmaking ticket to be canceled inside the event object passed into this function, specifically through the body property. So let's check if one exists by writing if in parentheses event.body, and then in squiggly brackets, let's parse out the event.body property because the body is a JSON formatted string and we want to convert it to an object. So type out const body equal JSON.parse and then in parentheses event.body. And let's also check if inside this body object if there's a ticket ID property. So type out if in parentheses body.ticket ID, then squiggly brackets, and if there is a ticket ID inside the body, let's set our local ticket ID variable to body.ticket ID. Now if the incoming request did not contain a ticket ID, then let's return a negative response from this function. So to do that, type out if in parentheses not ticket ID, squiggly brackets, response equal squiggly bracket again, status code colon 400 comma body colon JSON dot stringify, and then in parentheses and in squiggly brackets, error colon in quotes incoming request did not have a ticket ID. And then let's add a semicolon here, and again in this case if the request did not have a ticket ID, then let's return this negative response. And if there is a ticket ID, then let's make the request parameters for the GameLift stop matchmaking function by writing const GameLift request params, and let's set this equal to an object with one property called ticket ID, and the value for this property will be the ticket ID local variable that we defined earlier. And that's all we need to call GameLift stop matchmaking, so let's actually call it now by typing await GameLift dot stop matchmaking, and then in parentheses we'll pass in GameLift request params, and then underneath that we'll have dot promise parentheses dot then in parentheses data arrow squiggly brackets, and then underneath that we'll have dot catch in parentheses arrow squiggly brackets and a semicolon. And once again, this is a asynchronous function, hence the await, promise, then, and catch keywords. Of course, if this function call was successful, then the then function will be invoked. So in that case, let's make the response to return from this function positive by typing out response equal in squiggly brackets status code colon 200 comma body colon JSON dot stringify in parentheses and in squiggly brackets success colon in quotes matchmaking request has been canceled, and then we'll add a semicolon here at the end. And on the other hand, if something went wrong while calling this lambda function, then the catch function will be invoked and we should set the response to return to something negative by typing out response equal squiggly bracket status code colon 400 comma body .json.stringify in parentheses and then squiggly brackets error : error. And then we'll add a semicolon here at the end. And finally, to finish this function, return the response by typing return response, and then click on save up here to save your code changes. Alright, now we have to modify the access permissions in the policy attached to this lambda function so that it can call the GameLift stop matchmaking function. So let's go up and select where it says permissions, and then under execution role and role name, select your lambda function's role, and then that should take you to an IAM management console page, and under where it says permission policies and policy name, click on the policy attached to your lambda function, and then click on edit policy, and then click on the JSON tab. Also, I slightly misspoke. The permission policies that we have been modifying throughout this tutorial series with regards to lambda functions are technically assigned to the lambda function's role, not the function itself, and then the role is attached to the function. So let's modify this policy by adding another object in the statement array. So before the last closing square bracket and after this closing squiggly bracket, add a comma and then some squiggly brackets, and then inside here type out in quotes effect, and then colon in quotes allow, and then comma in quotes action, colon in quotes GameLift, colon stop matchmaking, and then comma in quotes resource, colon in quotes star, and then click on review policy when you're done typing that out, and then click on save changes. Okay, now let's go back to the lambda function so that we can test it. Keep in mind, once again, all the lambda code that we write in this tutorial series will be in a repository on GitHub linked in the description below, and there will also be test cases. So specifically for the stop matchmaking function, let's open up the invalid ticket ID event.txt file, copy the text inside. Let's go back to lambda, specifically the stop matchmaking function, and let's make a test event by clicking on this drop-down menu that says select a test event, then click on configure test events. Make sure create new test event is selected, and let's call this event invalid ticket ID event. And inside this JSON text editor, let's replace the text inside by pasting that text that we copied from that text file, and then click on create to create the test event, and then let's click on this test button to actually test the event, and then you should see execution results succeeded. And if we click on details to expand the details, this response makes sense, right? It has a body with an error object with the message inside of it saying specified matchmaking ticket does not exist, and that makes sense because we didn't pass in a valid ticket ID, we passed in the string dummy. But let's go ahead and actually test with a valid ticket ID, so a ticket that is linked to an active matchmaking request. So since I took a long time to record, my last access token has expired, so I'm going to generate a new one by going back to the Cognito hosted UI. So go to your app client settings in your Cognito user pool, click on launch hosted UI, and I'm just going to log in again with the same username and password that I've always been using. Again, try to stick with one user for now. Click on sign in. Take this code in the URL, copy it, go to the exchange code for tokens function, go to this drop down, select configure test events. Again, note that you don't have to do any of this if your access token from before didn't expire yet. So what I'm doing now can be skipped. So for the code, I'm just gonna paste in that code that I just got from the hosted UI. I'm gonna click on save, and I'll click on test using the tokens generated event. Now, if we look at our response, this should have the access token. So I'm just going to copy it from here. And then I'm going to go to the start matchmaking lambda function now, and I'm going to select this drop down menu. I'm going to select configure test events. Make sure you are on the valid access token event, and inside the headers here for the authorization property, just replace the token value inside here. So paste it in here, click on save, and then click on test. And after this function is finished executing, click on details to expand it, and take this ticket ID value here and copy it Now we have to do this really quickly, but before I do it, I'm just going to go to DynamoDB, specifically the matchmaking tickets table. I'm going to click on refresh here, and you should see no items linked to that matchmaking ticket ID. That's because that matchmaking request hasn't timed out yet. So let's go to the stop matchmaking function. Let's go back to the test events. So let's configure test events. Let's create a new test event. We'll call this valid ticket ID event. And for the ticket ID value, let's replace dummy with that ticket ID value that we copied from the start matchmaking function. We'll click on create and then click on test. And you should get this message. It should say, or this response that says success, matchmaking request has been canceled. And if we go back to the DynamoDB matchmaking tickets table and click on refresh this time, you should see an item of type matchmaking canceled associated with that ticket ID that you used. So yep, that looks about right. Note that if you didn't do it quick enough, the ticket may have timed out. So instead of matchmaking canceled, you may see matchmaking timed out here. That's okay. You can just go ahead and make a new matchmaking request and then go back to stop matchmaking and cancel that ticket again. And if that all works, then this function should be good to go. Let's go back to Lambda so that we can create one last Lambda function. So from here, go to functions and then click on create function. And this function will be used for polling the status of a matchmaking ticket. So the client will use this Lambda function periodically to determine whether or not their matchmaking request has reached one of the 4 final states that we talked about in a previous part of the tutorial. Otherwise, the client will assume that the matchmaking ticket is still in searching status. So we will call this function poll matchmaking, and then go ahead and click on create function. And because polling the status of a matchmaking ticket entails looking up the matchmaking ticket in the matchmaking tickets table in DynamoDB, we need the AWS SDK. So let's add a Lambda layer by clicking on where it says layer underneath the function name. Click on add a layer, and then select the layer that you've been using throughout this tutorial series, as well as the version, and then click on add. Alright, let's begin coding. So scroll down to the inline code editor, and inside here let's zoom in by pressing Ctrl+ a few times. And the first thing we're going to do is outside of this handler function, let's import some node modules. So type out const AWS equal require in parentheses and in quotes AWS-SDK. Then on the next line, const DynamoDB equal new aws.dynamodb in parentheses and in squiggly brackets region : in quotes the code of the region that you're operating in. For me, it is US-East-1. And then inside the handler function, let's get rid of everything that was already here by default, and then let's define some local variables. The first one will be called response, and then the second one will be called ticket ID. So similarly to the stop matchmaking Lambda function, requests to this function should contain a ticket ID in the body property of the event object passed in. The reason is that matchmaking requests are linked to tickets, and currently we may store information about that ticket in an item in DynamoDB that is keyed by the ticket ID. So let's first check if the event object has a body property by typing out if in parentheses event.body squiggly brackets, and if it does, then let's parse the body since it's a JSON formatted string by writing const body equal JSON.parse in parentheses event.body. And then let's check if this body object contains a ticket ID by writing if in parentheses body.ticket ID, and then squiggly brackets. If it does, let's set our local ticket ID variable equal to body.ticket ID. Now if the request doesn't have a ticket ID, then let's return a negative response from this Lambda function. So to do that, type out if in parentheses not ticket ID, and then in squiggly brackets response equal in squiggly brackets status code : 400 comma body : JSON.stringify in parentheses and in squiggly brackets error : in quotes incoming request did not have a ticket ID. Then add a semicolon here and then return response. But if there is a ticket ID, then let's make the request parameters for the DynamoDB getItem function. So type out const DynamoDB db request params, and let's set this equal to an object with a couple properties. The first one will be called table name, and the value for this property will be, in quotes, the name of the table that we will be searching for an item in. So in our case, it's going to be matchmaking tickets, and then the second property will be called key, and this will be an object that will have a property called ID, because right now in the matchmaking tickets table, each item, the partition key in each item is called ID, and because it is of type string, this ID property will be an object with a property called S. And then the value for this S property of the ID object of the key object is going to be the local ticket ID variable. And then just add a semicolon here at the end. And then we're going to make a local variable called ticket to eventually store the item object returned from the call to DynamoDB get item. And the ID of this ticket item should be the same as the ticket ID passed in through the request body. To actually call the DynamoDB get item function, let's write out await DynamoDB get item, and then in parentheses we'll pass in the DynamoDB request params, and then underneath that write .promise parentheses then in parentheses data arrow squiggly brackets, and then underneath that we'll have .catch in parentheses arrow squiggly brackets and a semicolon. If the call to the DynamoDB get item function was successful, then the then function will be invoked, and the data object return will have a property called item containing the item object associated with the ticket ID that we searched upon. Keep in mind though that there won't be an item property, or the item property will be an empty object or some other undefined equivalent value in the case where the get item function could not find an item in the matchmaking tickets table with that specific ticket ID passed in. So let's check if the item property even exists by writing if in parentheses data && data dot item and then squiggly brackets, and if it does, then let's set our local ticket variable equal to data dot item. And then in the response to return from this lambda function, let's send the ticket item. So type out response equal squiggly brackets status code :200 comma body :JSON.stringify, and then in parentheses and in squiggly brackets in quotes ticket :ticket. Once again, the property name in this case is in quotes because the value of the property is a variable with the same name as the property. So let's add a semicolon here at the end of the response object, and if the call to the DynamoDB get item function was not successful, then this catch function will be invoked, and in that case we should make the response to return from this lambda function something negative. So type out response equal squiggly bracket status code :400 comma body :JSON.stringify in parentheses and in squiggly brackets error :error, and then add a semicolon here at the end. And finally, to end this function, let's return the response, and then save your code changes by clicking the save button here on the top. And similarly to the getPlayerData lambda function, we have to modify the access permissions of this lambda function so that it can call the DynamoDB get item function. But instead of on the players table like getPlayerData did, we have to have this function be able to call the function on the matchmaking tickets table. So let's go up and click on where it says permissions, and then underneath where it says execution role and role name, click on this function's role. And then that'll take you to this IAM management console page. Underneath where it says permission policies and policy name, click on the permission policy attached to this lambda function role, and then click on where it says edit policy, and then click on the JSON tab. Then from here we're going to add another object to this statement array. So right before the last closing square bracket and after this closing squiggly bracket, let's add a comma and then a squiggly bracket. And then inside here, type out in quotes effect, in quotes allow, comma in quotes action, in quotes DynamoDB colon get item colon in quotes resource, and then, or sorry, in quotes resource colon in quotes go to DynamoDB, specifically the matchmaking tickets table in the overview tab, and then scroll down, and then underneath where it says Amazon resource name, copy this value to the right of where it says that, and then go back to the IM page, and then in quotes by the resource just paste in that ARN value, and then click on review policy, and then click on save changes. Now let's go back to the poll matchmaking lambda function so that we can test it. Remember that all the code will be in a GitHub repository linked in the description below, and for the poll matchmaking function specifically, let's look at the test events. So let's go to the invalid ticket ID event.txt file, and then copy everything that's inside here, and then go back to the poll matchmaking function, and then click on this select a test event drop down menu, click on configure test events, make sure create new test event is selected, and for the name of this event, let's call this invalid ticket ID event. And then inside this JSON text editor, let's replace the text inside by pasting the text from that text file, and then click on create, and then click on test to test this lambda function with that event. And then underneath where it says execution results succeeded, click on details to expand. And this may look a little odd, but this is actually what we expect. So you should see a response with a body, and the body is an empty object. That is because that ticket ID that we passed in through that test event was dummy. So there are no items right now in the matchmaking tickets table, and probably there will never be an item in the matchmaking tickets table with an ID called dummy. So because it won't be able to find an item with ID value dummy, then the getItem function won't have a data item property in it. Or sorry, the data object returned from getItem will not have an item property in it. So as a result, the ticket variable just never gets populated. And when you JSON stringify a property with an undefined equivalent value, then you basically, it's like the property doesn't even exist. So this is normal, this is an empty object, there's no ticket property in there because there was no ticket variable in the first place. Now let's actually go back to DynamoDB, specifically the matchmaking tickets table, so that we can test our function with an existing ticket ID. So hopefully, if you go to the items tab, hopefully you still have items in your tickets table, meaning not all of them have expired. If not, don't worry, just test the start matchmaking lambda function again like we did earlier in the tutorial, and wait for the matchmaking request to either time out or you can cancel it as well. And then once you have a ticket item in this table, just click on one of the item's ID attribute, and from here in this window that just popped up, copy the ID attribute value, and then go back to the lambda function and click on this drop down menu, select configure test events, and make sure create new test event is selected. And then we'll call this event valid ticket ID event. And then where it says dummy here inside the JSON formatted text, just replace this dummy text with the ticket ID that you just copied from an item in that table. And then click on create, and then click on test. And then let's quickly examine this item. We see the ID, we see the time to live, and we see the type. And if we go back to DynamoDB, and it looks pretty much the same. The ID is the same, the time to live attribute is the same, and then so is the type. They're both matchmaking canceled, so everything looks good here. Since that was the last lambda function that we had to write for this part of the tutorial, let's go ahead and add methods to our REST API for the lambda functions we wrote. So go to services, look up API gateway, and select API gateway. From here, click on the name of your REST API. So I named the GameLift tutorial API. And then from here, make sure you're in the resources section, and then make sure you have the root resource selected, and then click on this actions drop down menu and select create resource. And we're going to start with the get player data function. So I like to again call my resources the same name as the function. So we're going to call this resource get player data, and then click on create resource. And then making sure that the get player data resource is selected, select actions again, but this time select create method. And then in this drop down menu, click on this and click on Get, and then click on this check mark. And then from here, make sure for the integration type that you have lambda function selected. Make sure that this checkbox by where it says use lambda proxy integration is checked on. And then for the lambda region, make sure that the code of the region that you're operating in is selected. For the lambda function, just start typing out the name of that lambda function. And then of course you just saw you could have either chosen from the drop down menu, but if you type out the full name, usually it'll just autofill or autocorrect for you. And then click on save. And then click on OK. Now for all the methods for the new lambda functions that we just wrote in this part of the tutorial, they will all be cognito authorized. So let's add a cognito authorizer by clicking on where it says method request here, and then where it says authorization, by where it says none on the right, click on this pencil icon to edit the authorization. Select this drop down menu that says none, and then go down and select the authorizer under where it says cognito user pool authorizers, and then click on this check mark. Then now you should see a new field called OAuth scopes appear, and then let's click on this check mark to the right of where it says none. And for the scope here, let's go back to our cognito user pool settings, and like we did in the last part of the tutorial, in the app client settings for your user pool, if you look underneath where it says allow custom scopes, let's copy this custom scope value. Let's go back to API gateway, and where it says add scope, just paste that value in there and then click on this check mark. And that's pretty much it for the cognito authorizer. Now let's add another resource, so make sure the root resource is selected and then click on where it says actions and select create resource. And now we're going to be doing the start matchmaking function, so we'll name this resource start matchmaking and then click on create resource. And then make sure that the start matchmaking resource is selected before you click on the actions drop down menu again. But again, this time select create method now. And then in this drop down menu, select it, and this time select post, and then click this check mark button. Just to remind you guys again, the when do I choose get versus when do I choose post. For me, it's just a simple rule of if I'm passing data through the request body, then I make a method post. Otherwise, I'll just make it get. You don't have to follow this standard. This is just what I personally use. So again, same thing, integration type, make sure it's lambda function, use lambda proxy integration, turn that on by clicking the checkbox to enable it. Lambda region, just use the code of the region you're operating in. For the lambda function, just start typing out start matchmaking, and then select your function or do whatever, and then click on the save button and then click on OK. And then like the last method, let's add a cognito authorizer once again by clicking where it says method request, and then for the authorization, just click the pencil icon, click on the drop down menu, select GameLift tutorial authorizer, click on this check mark button to update the authorization. Then in the newly shown OAuth scopes field, click on this pencil icon to the right of it, and then for the scope, luckily I have that custom scope from the user pool app client settings copied to my clipboard still, so I'm just going to paste it here again and then click on the check mark again. And let's add another resource, so make sure the root resource is selected before you click on actions, and then select create resource. And then this is going to be for the stop matchmaking lambda function, so we'll name this resource stop matchmaking. And then click on create resource, and then making sure that the stop matchmaking resource is selected, click on actions and then select create method, and then click on this drop down menu and select post, and then click on this check mark button. And then for the integration type, once again, lambda function, same as always, use lambda proxy integration, make sure that checkbox is checked on. Lambda region, just use the region or the code of the region that you're operating in. For the lambda function, just start typing out the name of the lambda function, and then click on save once you're done, and then click on OK. Then let's add a cognito authorizer to this method by clicking on method request up here, and then for the authorization, just click on this pencil icon, click on the drop down menu, select your cognito user pool authorizer, click on the check mark button, and then by where it says OAuth scopes, click on the pencil icon, and then for the scope, luckily I still have that custom scope from the cognito user pool app client settings still copied to my clipboard, so once you have that copy, just paste it in here and then click on the check mark button. And let's add one more resource for the final lambda function. So make sure the root resource is selected, then click on actions and then select create resource. And then for the resource name, again, the last function is called poll matchmaking. So we'll name this poll matchmaking, and then click on create resource. And then making sure that the poll matchmaking resource is selected, click on actions again, and this time click on create method. And then in this drop down menu, just select post and then click on this checkmark value. And then once again, integration type, still lambda function, use lambda proxy integration. Yes, we want that, so make sure the checkbox is checked on. Lambda region, just use the code of the region you're operating in. And then for the lambda function, just type out the name of the function. And then make sure that the lambda function is in that field, and then click on save and then click on OK. And let's add a Cognito authorizer one more time. So click on method request, by where it says authorization, click on this pencil icon, click on the drop down menu, select the Cognito user pool authorizer. In my case, it's called GameLift tutorial authorizer. Click on the checkmark button, and then in this newly appeared OAuth scopes field, click on the pencil icon, and then for the scope, just paste in that custom scope that we copied earlier from your Cognito user pool app client settings, and then click on this check mark. And then once that's all done, make sure you have the root resource selected, and we are now going to deploy the API. So click on actions, click on deploy API, and then for the deployment stage, select this drop down and just select test, the stage that we've always been using, and then click on deploy. And now the API, if you click on this sideways caret symbol or triangle by where it says the test under where it says stages to expand this stage, now the GameLift tutorial API should now include API routes that map to these new methods that we made for this API that should be linked to these new lambda functions that we made. So the last thing we're going to do now in this part of the tutorial is just make sure that the API mapping for the new methods we created is correct. So go ahead and open up Postman. Once Postman is opened up, let's make a new request for each lambda function that we just made. So go to new up here and then click on request, and we'll call this, we'll call each request name the same name as the lambda function that we're going to call. So we'll start with get player data, and then for the collection or folder to save to, just select the collection that you've been using throughout this tutorial series. For me, it was the GameLift tutorial collection, and then click on the save button here at the bottom. Then go back to API Gateway and go to the get player data resource, specifically the get method. So click on where it says get, and by where it says invoke URL, just copy this URL, and then go back to Postman, paste it in here where it says enter request URL, and press Ctrl S to save this request. We'll get back to this request later, but let's just first, I want to keep making new functions for each request before we actually test them. So let's make a new request. Click on request again, request name, so we'll make one for start matchmaking, and then the collection that you selected for the get player data request, that collection should be selected for this one, so we'll keep using the same collection. Just click the save button again, and then let's go back to API Gateway. This time under where it says start matchmaking, click on where it says post, and for the invoke URL, just go ahead and copy that. Go back to Postman, paste it where it says enter request URL, and since this is a post method, not a get method, let's click on where it says get here, and from this drop down menu, select post, and then press Ctrl S to save that request. Let's make a new request for another API method by clicking where it says new up here, go to request. For the request name, let's make one for stop matchmaking now. And then let's click on save to GameLift tutorial collection. Once again, we'll just keep using the same collection. Go back to API Gateway. This time under where it says stop matchmaking, click on where it says post, and by the invoke URL, just copy this URL. And then go back to Postman, and then where it says enter request URL, just paste the URL in there, and then where it says get, of course, select this and select post because this API method is of type post, not get. Press Ctrl S to save that, and let's make one last request for the last API method. So click on new, click on request, and for the request name, this will be for poll matchmaking. Keep using the keep using the same collection, click on Save to GameLift Tutorial Collection, go back to API Gateway, and then under where it says Poll Matchmaking, select Post, and then copy the invoke URL, and then go back to Postman, and then paste the URL inside where it says Enter Request URL, and where it says Get, click here, select Post because this API method is of type Post, and press Ctrl S to save. Now let's make sure that each API method is cognito authorized by clicking send for each of these requests, and we should see message unauthorized for all of them when we do this. So that was poll matchmaking. Let's go to stop matchmaking. Let's click on send. We do see message unauthorized, and then let's go to start matchmaking, click send. We also see message unauthorized, and then finally for get player data, let's also click send, and we do see message unauthorized because once again, we did not provide an access token through the authorization header in the request. But to ensure that each of these URLs are mapped to the right lambda function, we have to pass an access token through the authorization request header and examine the response returned. So let's get an access token like we have done before by going back to Cognito, specifically the user pool settings and specifically the app client settings, and then go and launch the host UI, and let's log in once again. So again, try to use the same user that you've been using before and enter a username and password, click sign in, and then using the code from up here in the URL, let's go ahead and copy that. Let's go back to Postman, and if you followed the last part of the tutorial, you should see or you should have made a request for the exchange code for tokens API method. So go to the request you made in Postman for the exchange code for tokens API method. And then if you go to the body here, where it says code in quotes on the right here, just get rid of the original code that was here last time, paste it in, and then click send. And then let's press Ctrl S to just save this request again. And then you should see in the response below that we do indeed get an access token. So let's copy this access token here by pressing Ctrl C, and then go back to the get player data request, and let's go to headers, and then let's add a new header that is called authorization. And then for the value, just go ahead and paste that access token that we got from the exchange code for tokens lambda function, and then click on send. And now because we passed in a valid access token, you shouldn't see message unauthorized. In fact, you should get the item in the players table that corresponds with the sub ID linked to this access token. So as you can see, we have the Cognito sub ID, the number of losses, as well as the number of wins. And don't forget to press Ctrl S to save your request. And the neat thing about Postman again is that we can copy this header, this authorization header that we just added to this request, and paste it in for other requests. So click and hold your mouse on this empty description box to the right of where you pasted that access token, and then just drag your mouse to where it says authorization. Let go and press Ctrl C to copy the header. And then let's go to the start matchmaking request, and then go to headers, and then in this empty key box here, just press Ctrl V to paste that authorization header. And then we can click on send, and if the API mapping is right, then that error message, actually that response, error incoming request did not have a latency map, that's actually okay. Because we're only just testing if this API route maps to the start matchmaking lambda function, which it clearly does, because right now the only function we wrote that ever returns this kind of error message, incoming request did not have a latency map, is the start matchmaking function. So just press Ctrl S to save that function, or to save that request. Now let's go to the stop matchmaking request and do the same thing. Go to where it says headers, and let's click on this empty key box here at the bottom of the headers, press Ctrl V to paste that authorization header with that same access token, click on send, and the response you get back, it'll say error incoming request did not have a ticket ID. Now, although this is a valid response from the stop matchmaking lambda function, it doesn't really tell us that the API mapping is correct. It doesn't ensure that this API route URL is mapped to the stop matchmaking lambda function, because technically if we go to the poll matchmaking function, go to the headers, and we paste in that same authorization header with that same access token here at the bottom of the headers and click send, we'll get the same response error message. We'll get error incoming request to not have a ticket ID, because both the pull matchmaking and stop matchmaking lambda functions expect requests coming into those lambda functions to contain a ticket ID in the request body. Now, obviously it's for different purposes, right? Pull matchmaking is using that ticket ID to retrieve a specific item in the matchmaking tickets table, whereas the stop matchmaking lambda function is using that ticket ID to cancel an existing and active matchmaking request if possible. So just to test the API route mapping, let's add a request body to the stop matchmaking request by clicking on where it says body to the right of where it says headers, and click on raw, and then where it says text in orange, click on that and select JSON from the drop-down menu. And then let's add a pair of squiggly brackets here. And inside this JSON object, let's type in double quotes, ticket ID, and then colon, in quotes again. This doesn't have to be a valid ticket ID. Again, we're just testing the API mapping. So let's just write dummy, and then let's click on send. And see, now this response from the API method now looks like it came from the stop matchmaking lambda function. It actually looks like it came directly from the GameLift stop matchmaking function from the AWS SDK. You see the error message, specified matchmaking ticket does not exist, which is true. There's no ticket in circulation right now with that ID dummy. So let's actually do the same thing for the pull matchmaking request. So press Ctrl S to save this request, and then let's copy this text here inside this request body, go to the pull matchmaking function now and go to where it says body to the right of where it says headers, select raw, and then where it says text in orange, select that, and from the drop down menu select JSON. And inside this text box, just paste in that same request body that we used for the stop matchmaking function. And if we click send this time, you're going to see that the response should be a lot different. So in this case, because there's no ticket item in that matchmaking tickets table with a ID with the value of dummy, we get back an empty object as a response, because like I said earlier, when you call get item and DynamoDB can't find the item by the request parameters that you specify, then it just won't return any item because the item simply does not exist. So from the looks of it, let's just press Ctrl S to save this request, but from the looks of it, it looks like we set up all those lambda functions correctly. We wrote them all out, we mapped them to our API, and we tested them all in the Lambda console and in Postman. And that will conclude this part of the tutorial. We have finished setting up our client service with some new functions so that now the client has the API endpoints it needs to make a matchmaking request, cancel a matchmaking request, check on the status of a matchmaking request, and get player data. All of these API methods will help the client get into a potential match and later join the game server process that the match is hosted on. Just want to end the video by thanking our patrons on Patreon. If you guys want to help support the channel, then please consider donating. Any donation amount will help us create more content for you guys. And if you enjoyed the video, then please like, comment, subscribe, join our Discord, follow us on our other social medias. Links to everything will be in the description below, and see you guys in part 7.